Hello class, this is your teacher Miss Palmer. Thank you for trying out my first video guided notes. As we start rational functions, we're going to begin by looking at exponents and how to simplify expressions. So as you remember, an exponent tells how many times a base is multiplied by itself. We would read this power as 5 squared. You can see bases in various forms, and every base has its own exponent. If you don't see an exponent on a base, it is automatically 1. So you can write in a 1 wherever you don't see an exponent. Now, to make it short, we're going to go over these rules of exponents. And our first rule is if you multiply like bases, such as 5 squared times 5 to the 6th, how many 5s are being multiplied? Well, you will find that you add 2 plus 6 together, and that gives you a total of 8 5s being multiplied, or what we call 5 to the 8th. The same works for letters. Now, if we have 7 times 6, those are not like bases, so we're just going to multiply those numbers and get 42. But y to the 5th and y to the 1st are like bases, so we will add 5 plus 1 and get y to the 6th. Now I want you to pause and finish the section of multiplying like bases by adding exponents. You can check your work when you're all done using one of the answer keys provided in the classroom. Now we're going to look at the quotient rule. Quotient means division. If you're dividing two quantities with the same base, then that means y to the 6th divided by y to the 1st. You would subtract the exponents, and you would be left with y to the 5th. Now, I'm going to skip over the middle one so you can try that one, and I'm going to go to the last one. Now, when you have multiple like bases, you treat each individually. 10 and 15 are regular numbers as a fraction. So you want to reduce 10 15ths like you would normally reduce a fraction. They both divide by 2. They both divide by 5, which gives you 2 thirds. So we have a 2 in the top and a 3 in the bottom. A to the 7th can divide with a to the 5th, which gives you a total of a squared, because 7 minus 5 is 2. B to the 9th over b to the 9th gives you the same as b to the 0th. Or you would notice that anything divided by itself equals the number 1. So we can cross those out, and we can cross b to the 0th out because it equals the number 1. So our final answer is 2a squared over 3. Go ahead now and complete the middle problem on your own. Now that you have finished, flip in your packet to the next page where we're going to discuss the zero exponent rule. We sort of already touched on it in the previous example. Whenever you have division of the same quantity by the same quantity, we know that it equals the number 1. Well, using our exponent rule of division, 8 is a matching base, and we can subtract its exponents. Well, 2 minus 2 gives us 8 to the 0th, and we know that anything divided by itself equals the number 1. So therefore, anything raised to the 0th power will also equal the number 1. So, when you look at this quantity inside parentheses is raised to the 0th power, think of your zero exponent rule, which is a shortcut. We know it's automatically going to equal the number 1. Section. Another very important exponent rule is what we call the negative exponent rule. Exponents, those little numbers written to the right of your base, they do not like to be negative. So therefore, if you ever have a negative exponent, you are going to place the power in the denominator to rewrite the power with a positive exponent. So let's do an example. For example, b squared over b to the 5th. Well, that is the same as b to the 2 minus 5. And that is the same as b to the negative 3. But instead of calling this b to the negative 3, we can resituate our base b into the denominator, and now his exponent becomes positive. So think of it, exponents are happy people. They do not like to be negative, so they have to move to the denominator to become positive, or vice versa. If you would like to see the long form of why this is true, b squared is the same as b times b. B to the 5th is same as b times b times b times b times b. You will see that 2 pairs of them cancel and leaves 3 being multiplied in the denominator. Whenever anything is divided by itself, the number 1 always remains. So you can see why b to the negative 3 equals 1 over b cubed. Now you can use the shortcut to do these, such as 2 to the negative 3. Right now he's negative, so we are going to put him in the denominator and his exponent becomes positive. And then don't forget there's automatically a 1 in the numerator if you don't already have something there. Go ahead and pause and complete the remaining problem on your own of negative 3 to the negative 3rd power. Let's look at our last page now, which has our rules of exponents which relate to exponents raised to exponents. So because they are both indicating how many times our base is being multiplied, you're going to find that when a power is raised to a power, we're going to multiply the exponents. So x squared 8 times is the same as x to the 2 times 8, and you can just jump to say that that is x to the 16th. Now go ahead and try the second problem on your own. Let's look at our second power rule. This is the power of a product. If you have multiplication inside parentheses and it's all being raised to a power, then that means every single factor is being raised to that power. So if we have 4x cubed yz all being cubed, that means you need to cube every single piece inside. So I'm going to go ahead and write in the exponents on each piece, and then I can cube each piece. So 4 to the 1st cubed is 4 cubed. X cubed cubed is x to the 9th. Y to the 1st cubed is y cubed. And z to the 1st cubed is z cubed. Now you'll find when you have a number that's being raised to a power, this actually can equal a value. So you can either compute in your head or on your calculator that 4 cubed is the same as 64, and then bring down your remaining variables with their exponents. And that is your answer. Let's try the next one. Now, you always want to start with your power rule. So we're going to raise every single factor to the negative 2. So we get 7 to the negative 2, x to the negative 2, and y to the positive 4. Now, you want to locate which bases have negative exponents, and we want to rewrite them in the denominator. So our 7 is going to the denominator, so it gets a positive 2. Our x is going to the denominator, so it gets a positive 2. Y to the 4th is happy in the numerator, so he stays in the numerator. We are almost done. The only thing we need to do is write that 7 squared is the same as 49. So our final answer is y to the 4th over 49x squared. Go ahead now and complete the rest of this section on your own with the last problem. Our last rule we're going to look at is very similar to power of a product, it's just power of a quotient. So If you have quantities being divided and the whole entire fraction is being raised to an exponent, then that means each piece is being raised to that exponent, both the numerator and the denominator. So on our first example, 3/5 squared, that means the 3 is being squared and the 5 is being squared. Now remember, numbers have a value, so 3 squared is 9 and 5 squared is 25. That is your answer. Now let's look at the problem below. On this problem below, we must start by cubing each piece. So 3 to the first cubed becomes 3 cubed. A to the negative 4th cubed, you have to multiply your powers, you get a to the negative 12th, over b to the 7th cubed. 7 times 3 is 21, so it's b to the 21st. Now hopefully you spot the negative exponent on our a, and you know that it's going to need to resituate itself in the denominator. 3 cubed is perfectly fine, so it becomes 27. Our a, though, needs to go to the denominator, so it gets a positive 12 exponent. The b is happy where he is, so b to the 21st stays right where he is. You're going to be finishing the last questions on your own, the last two. So hopefully this was a helpful video and you can use this as your guided notes as you continue practicing your simplifying of exponents.